Welcome back for another deep dive with us. Today we're looking at something pretty interesting, the connection between fairy circles and natural hydrogen. So you might have heard about hydrogen as a clean fuel, but have you heard about finding it naturally?
You know what's so intriguing? It's this almost mythical phenomenon and how it connects to our energy needs. I mean, fairy circles, they've been the stuff of stories for ages,
Mm.
right? Tales of fairies and magic. But now they might hold the key to a cleaner energy future.
Okay, so let's break this down. What exactly are fairy circles?
So picture this. You've got a bare patch of earth, perfectly round, and it's got this vibrant ring of grass or shrubs all around it. You find these a lot in arid grasslands. They make this unique pattern on the landscape. And people have come up with so many theories over the years, everything from termites to even fairies dancing under the moon.
So what about some of the leading theories about how they form, and why have termites been ruled out?
Well, early theories, they focused on termites a lot, or how plants compete for resources. But newer research, especially in Australia, points to something different: natural hydrogen seeps.
Hydrogen seeps. So the hydrogen that we're looking at as a fuel is seeping out of the ground.
Exactly. And scientists have actually found higher amounts of hydrogen in the soil around these circles, especially along the edges. This suggests that hydrogen created deep underground. It's moving up and affecting how the plants grow.
So could these fairy circles be like a giant arrow pointing to hydrogen hotspots?
You know they might be. In the past, we kind of stumbled upon natural hydrogen reserves by chance. But now, with tools like satellite imagery and even Google Earth, we can potentially pinpoint these hydrogen-rich areas without even leaving our desks.
So I could open up Google Earth right now and start hunting for fairy circles. How would I even recognize them?
Well, scientists are actually using satellite imagery, especially from resources like Landsat 9, to scan for these unique circular formations. They look for specific clues in the vegetation patterns and soil characteristics that might suggest the presence of hydrogen.
What would those visual cues look like to someone who's not a scientist, though? What exactly are we looking for in these images?
Well, the most obvious sign is the circle itself. Fairy circles really stand out because they've got that perfect circular shape and the sharp contrast between that bare center and the surrounding vegetation. You'll often see the vegetation around the circle, looking healthier and more vibrant than the surrounding grassland. That can be another indicator.
Okay, so if we see a ring of lush vegetation surrounding a barren patch, that's a good starting point. Are there any other things we should keep in mind?
Yeah, pay attention to the size and distribution of the circles. Fairy circles can range in size from a few meters to tens of meters in diameter, and they often appear in clusters, creating these distinct patterns on the landscape. You also might want to look for areas with known geological features that favor hydrogen generation, like fault lines or areas with specific rock types.
So if we combine our knowledge of geology with these visual cues from the satellite images, we might be able to narrow down the search for potential hydrogen hotspots.
Exactly. It's like putting together pieces of a puzzle. By combining satellite imagery analysis with geological data, we can increase our chances of finding these elusive hydrogen seeps. And who knows, maybe we'll even discover more about these fascinating fairy circles along the way.
This is incredible. This seems like a really exciting time to be involved in this kind of exploration. So what are some of the next steps after a potential fairy circle is identified using satellite imagery?
Well, after identifying a potential fairy circle using satellite imagery, researchers will typically conduct ground-based surveys to confirm their findings. This might involve collecting soil samples to analyze gas concentrations, studying the vegetation patterns up close, and conducting geophysical surveys to map out those subsurface features.
I'd love to learn more about how those ground-based surveys work and what kind of information they reveal. But first, let's take a step back. We've talked a lot about how fairy circles might indicate hydrogen seeps. But how exactly does hydrogen form underground in the first place?
That's a great question. One of the key processes is called serpentinization. It involves water reacting with iron-rich rocks deep underground.
That sounds like a pretty intense reaction. Could you elaborate a bit on why this process creates hydrogen?
Sure. During serpentinization, as water interacts with those iron-rich rocks, the water molecules actually split apart, and this splitting releases hydrogen as a byproduct.
So it's the interaction between the water and these specific rocks that leads to the release of hydrogen. It's fascinating how geological processes can produce something as valuable as hydrogen fuel.
Absolutely. And it's this naturally occurring hydrogen that's migrating upwards and potentially contributing to the formation of fairy circles.
And now we've talked about how to spot these potential hydrogen hotspots. But the big question is, can we actually turn them into usable fuel?
That's where things get really interesting. You see, just because hydrogen is seeping out doesn't mean it's accumulating in amounts that are economically viable. We need to understand the types of geological formations that can trap and store hydrogen underground, much like reservoirs for oil and gas.
That makes sense. So what kind of geological formations are we looking for? What makes a good hydrogen trap?
To answer that, we need to understand how hydrogen travels from deep underground to the surface. Picture it using pathways like fault lines as underground highways. Then it might encounter a barrier, like a dense, impermeable rock layer. Think of rocks like dolerite. It's similar to basalt, salt deposits, or volcanic sills. These act like walls trapping that escaping hydrogen.
So it's like a geological game of capture the flag, hydrogen's trying to escape, and these formations are trying to trap it. What are the chances of actually finding these hydrogen traps in the vicinity of fairy circles?
Well, that's what makes this research so exciting. Scientists are just beginning to explore the link between fairy circles and potential hydrogen reservoirs. While we don't have all the answers yet, the early findings suggest that these circles could be valuable indicators.
It's like these fairy circles are leading us on a treasure hunt for clean energy. What are some of the key locations around the world where researchers are focusing their efforts?
Well, Australia, where a lot of the research on fairy circles and hydrogen is taking place, that's certainly a hotspot. There's also growing interest in exploring for natural hydrogen in parts of Brazil, Russia, and even the United States.
This is truly groundbreaking. We could be sitting on a whole new clean energy source right beneath our feet, and these fairy circles might be the map we need to find it.
It's a possibility that has a lot of people excited. While there are still challenges and unknowns, the potential of natural hydrogen is immense.
This deep dive is already proving to be incredibly insightful. Before we move on to the next stage of our exploration,
Let's delve into some specific case studies that illustrate how scientists and companies are using these strategies to uncover natural hydrogen deposits.
sounds fascinating. I'm eager to learn more about how these discoveries are unfolding.
So let's start with this fascinating case in France. There was this team led by Philippe de Donato. They were looking at old mining records in the Lorraine Basin, assessing methane risks in these abandoned coal mines. But their analysis, it revealed something much bigger. A possible reserve of 46 million tons of natural hydrogen.
Wow, that's a remarkable discovery. What are the implications of finding a reserve that large?
Well, it sparked a lot of interest in natural hydrogen exploration across Europe. Experts believe that France alone could potentially produce enough natural hydrogen to meet a good chunk of their decarbonization targets.
That would be a game changer. And all of this from looking at old data. What other case studies highlight this shift toward natural hydrogen exploration?
Well, on the other side of the world in Australia, a company called Gold Hydrogen has been making waves. With their drilling project on the York Peninsula, they were looking at a well that's been known to contain hydrogen since the 1930s.
Really? So how are they planning to extract the hydrogen?
Well, they're using modern drilling technology. And with a focus on clean energy, they've been able to confirm that hydrogen is persistently present in the area, potentially adding another piece to the natural hydrogen puzzle.
These discoveries are so exciting. But the big question is, can we actually turn these hydrogen hotspots into usable fuel?
That's the million-dollar question, right? Finding the hydrogen is only half the battle. We need to determine if it's economically viable. It's cleaner than fossil fuels, sure, but there are still challenges and uncertainties regarding its extraction, storage, and distribution.
Okay, so let's talk about extraction. Is it as simple as just drilling a hole and letting the hydrogen flow?
Well, it's a bit more complicated than that, but we can often use existing technologies from the oil and gas industry for natural hydrogen extraction. Remember, this hydrogen is often trapped under pressure beneath those impermeable rock layers. So drilling a well into that reservoir, it can release the pressure, allowing that hydrogen to flow to the surface.
So thinking about those drilling rigs used in oil and gas extraction, would extracting natural hydrogen involve similar massive industrial operations?
Not necessarily. The scale of natural hydrogen extraction, it could vary depending on the reservoir size and location. Some experts envision smaller, more localized operations that could power communities directly from these natural sources.
That's a really fascinating concept. Imagine communities generating their own clean energy from hydrogen wells right in their backyard. What are some of the challenges or potential downsides to extracting natural hydrogen, though?
One concern is the potential for methane leaks. Remember, some hydrogen reserves are found alongside methane, which is a much more potent greenhouse gas than carbon dioxide. So if we're not careful, Extracting natural hydrogen could inadvertently release methane into the atmosphere, which would reduce some of the environmental benefits.
That's a really crucial point. It's not just about finding the hydrogen, it's about extracting it responsibly and minimizing any environmental impact. What about storage and transportation? Hydrogen is known to be tricky to handle, right?
It is. Hydrogen is a very light and volatile gas, which makes storage and transportation more complex than traditional fossil fuels. We can't just pump it into existing pipelines or store it in conventional tanks.
So what are the options then? How do we move this hydrogen from those fairy circle hotspots to where it's needed?
There are a few promising avenues being explored. One is to use existing salt caverns, which are already used for storing natural gas, as potential hydrogen storage sites. Another approach is converting the hydrogen into ammonia, which is easier to transport and store, and then converting it back to hydrogen at the point of use.
So we're talking about repurposing existing infrastructure and exploring new technologies. This is starting to sound like a pretty complex and multifaceted challenge. Is it even realistic to think that natural hydrogen could become a major player in our energy future?
Well, that's the big question that researchers and industry experts are grappling with. The potential is definitely there, but we need more data, more research, and technological advancements to make natural hydrogen a truly viable and sustainable energy source.
It's a race against time, and the stakes are high. As we move away from fossil fuels, we need to explore all viable options, and natural hydrogen is definitely a contender. But before we crown it the champion of clean energy, we need to address those economic and logistical hurdles.
Exactly. It's a fascinating field with immense potential, but we need to approach it with a healthy dose of realism and a commitment to responsible development. Before we wrap up our deep dive into fairy circles and natural hydrogen,
Hold on. There's one more aspect we haven't touched on yet. The potential environmental impacts of scaling up natural hydrogen extraction. Are we talking about a truly green energy source? Or are there hidden downsides we need to consider?
you're right, that's a crucial part of the conversation. We need to understand the full life cycle impacts of natural hydrogen, from exploration and extraction to transportation and use, to ensure it truly aligns with our goals for a sustainable future.
Let's dive into those environmental considerations in more detail. We've talked about natural hydrogen as this clean energy source, but even though burning hydrogen only produces water, doesn't automatically mean it's totally environmentally friendly, right?
You're absolutely right. We can't just focus on those tailpipe emissions. While hydrogen itself is clean burning, we have to think about the potential environmental impacts throughout its entire life cycle.
So what are some of the potential environmental impacts we should be aware of?
Well, one concern is habitat disruption. During those exploration and extraction phases, remember we're talking about drilling into the earth. And this can have impacts on ecosystems, especially in areas that are sensitive or remote.
So just like any extractive industry, we need to be careful about where and how we drill to make sure we're minimizing the damage to the environment. What other environmental factors do we need to think about?
Another issue is the potential for hydrogen leakage. Throughout the entire supply chain, hydrogen is a tiny molecule, so it can easily escape from pipelines, storage facilities, and even fuel cells.
So even if we're super careful about extracting it, we could still lose some of that valuable hydrogen.
Exactly. And while hydrogen itself isn't a greenhouse gas, when it leaks into the atmosphere, it can react with other compounds, and that can indirectly contribute to global warming.
Interesting. So it's not as simple as just swapping out fossil fuels for hydrogen. We really have to think about the whole picture to make sure we're not creating new problems. While trying to solve the old ones, what can we do to mitigate these potential environmental risks?
Well, when it comes to exploration, using those remote sensing technologies like satellite imagery can help to minimize the need for those extensive ground-based surveys, which reduces habitat disruption. And during extraction, careful well design and monitoring are really crucial to prevent leaks and minimize the release of things like methane and other gases.
So it sounds like a lot depends on just being smart and strategic in our approach. What about preventing those hydrogen leaks during transportation and storage? Are there any solutions for that?
Yeah, researchers are working on new materials and technologies for hydrogen pipelines and storage tanks that are less prone to leakage. And remember that ammonia conversion process we talked about earlier, that could also play a role in minimizing those transportation-related leaks.
So we're talking about repurposing existing infrastructure and exploring new technologies. It really sounds like we're on the cusp of a new era of energy exploration and innovation, and natural hydrogen is right there at the forefront. But we need to move forward cautiously and balance those potential benefits with the need to protect the planet
I completely agree. As with any new technology or energy source, it's crucial to have a thorough and transparent assessment of the environmental impacts. We need to be certain that natural hydrogen lives up to its promise as a clean and sustainable solution.
Well, this brings us to the end of our deep dive into fairy circles and natural hydrogen. It's been quite the journey, exploring these mysterious formations, uncovering the potential of this hidden energy source, and thinking about what a sustainable future might look like. What's your biggest takeaway from all of this?
For me, it's a reminder that our understanding of natural hydrogen is still evolving. There's so much we still don't know. But the potential is just enormous. It's a call to action for scientists, engineers, policymakers, really all of us, to explore this resource responsibly and make sure it benefits both humanity and the planet.
Well said. It's truly a story of science, innovation, and how interconnected our planet systems really are. Who knows what exciting discoveries await us? As we keep learning more about natural hydrogen, it's certainly an exciting time to be following this field. We'll leave you with this thought. What if these mysterious fairy circles, once just the stuff of myths and folklore, actually hold the key to a cleaner, more sustainable energy future? Thanks for joining us on this deep dive. Until next time, keep seeking knowledge and challenging those assumptions.
If you enjoyed this video, please consider supporting this channel by hitting the subscribe and like buttons. This will help the channel grow and expand on the journey we have begun together here at AI Meets You.